Ladies and gentlemen, welcome to the video notes for Chapter 4, Section 3 in your geometry textbook covering congruent triangles. What we're trying to do in this section is we're trying to expand the word congruent and discuss what it means. We've discussed what the word congruent means in terms of line segments and in terms of angle measure. Now we're trying to discuss what it means when we use it to discuss shapes. So we're talking about polygons on this particular slide. What this theorem, what this says, well, it's not really a theorem, it's really more of a definition. What we're saying here is that we can apply the word congruent to polygons, assuming that they have certain properties, because two polygons are congruent if and only if all of their corresponding parts, which would be all of their angles and all of their sides, are congruent. So in this case, we're specifically going to talk about triangles because that's the chapter we're in. We're talking about triangles in this chapter. In other chapters, we'll talk about quadrilaterals, we'll talk about other polygons beyond that, but in this chapter, we're focused in on triangles. Now, what I mean when I say corresponding parts is I'm saying we have two different triangles. We can state that those two different triangles are congruent if and only if for every angle in the first triangle, there is a matching angle in the second triangle, a congruent angle. For every side in the first triangle, there is a congruent side in the second triangle. In other words, we're trying to state that the two triangles are not only the same shape, but also exactly the same size. Same size and same shape. So that's what congruent means when we talk about polygons. It means same size, same shape. So, here we have a triangle congruence statement. Triangle ABC is congruent to triangle DEF. That statement is true if and only if the 6 sets of corresponding parts, that's 3 sets of angles and 3 sets of sides, are congruent. So what we can do here is, since we're given the congruence statement, that means that we have 6 other congruence statements that we can write directly from that statement. If we look at the first letter in each name, which is A and D, that tells us that angle A must be congruent to angle D in these triangles. So we can go in and we can mark those with a single arc. Okay, so that's the first letter in each name, tells us our first set of angles. If we then go to the second letter in the name, the middle letter in each name is B and E. That implies that angle B is congruent to angle E in these triangles. So we would go in and we'd mark those two angles as being congruent. Now notice I'm using a different number of arcs because that indicates that while they are congruent to each other, angle B is congruent to angle E, they are not congruent to angles A and D. It's a different measurement than the first set. And then finally we've got the third and final letter in each name, C and F. So angle C must be congruent to angle F. And we would mark those with 3 arcs. So those are our 3 sets of angles. Notice that every angle in the first triangle has a matching angle in the second triangle. Okay, that's what we're saying when we say corresponding parts. There is an angle that matches in each triangle. So then we move on to side links. Side links can also come from the name. If we look at the first 2 letters in the name, we have AB and DE. This indicates that segment AB is congruent to segment DE. So we'd go in and we'd mark those as being congruent with a single dash mark. Okay? We can do the exact same thing with the second and third letters in each name. BC is congruent to EF. So BC and EF are congruent. Again, notice I'm using a different number of dash marks to indicate that those 2 sides are congruent than I did for the first 2 sides, because while they are congruent to each other, they are not congruent to the first set. The final set would be the first and last letters, AC and DF. So AC is congruent to DF. Put 3 dash marks on AC, 3 dash marks on EF. The only way that this congruent statement is true is if all 6 of these statements are true. So the only way this is true is if all of these are true. Okay? And the same thing applies the opposite direction. The only way that these 6 are true is if this is true. Okay, it's if and only if, which makes it a biconditional, means it goes both directions. Okay? All right, so the first skill in this section we're going to cover on this video, and then the other theorem and the other skill is going to be a second video. The first skill in this section is we're going to give you a picture that contains 2 triangles, and we're going to ask you to verify that those 2 triangles are congruent by stating all 6 pieces of information, all 3 sets of angles and all 3 sets of sides. And then you turn around after you've stated those 6 and you write the triangle congruence statement. So let's take a look at one of those problems. Here's an example. Notice we have 2 triangles in this picture, and we are going to verify that those 2 triangles are in fact congruent. We're going to show that they're congruent by stating all 6 sets of congruent parts. After we finish that, we're going to write a congruent statement for these 2 triangles. So if we look at the picture, some of the information is already given to us. We have that side BC is congruent to side AD. The way that we know that is we have 1 dash mark, notice what I'm marking in blue, on those sides already. Okay, there's already 1 mark there, which means that it was given that those were already congruent. The same can be said of AB and CD. They are already marked with 2 marks, which makes them congruent. Now, before we talk angles, there is 1 more set of sides to indicate. So if we look at the 2 sides that we've already marked, the third side of each of those triangles, the third side of the top triangle, is this side, AC, and the third side of the bottom triangle is also AC. So we need to come up with a reason why that third set of sides is congruent. And the simple explanation is that third set of sides is congruent because it's the same exact line segment. AC is the same, they share that side, they have a common side. So we can go ahead and we can mark that as being congruent because if they share a side, that is one of our properties from earlier in the book. That's called a reflexive side. Every line segment is congruent to itself. So since both triangles have AC as a side, the reflexive property says that AC must be congruent to itself, which gives us our third set of sides. So there's our 3 different side statements. Now let's go to angles. With the angles, only one of them was marked to begin with. That is, angle B is congruent to angle D. And the reason for that is both of those angles are labeled with a 90-degree angle. Notice we have a boxy symbol on both angle B and angle D. That indicates that both those angles equal 90 degrees, which means their measures are equal, which means they're congruent. I believe that was one of our perpendicular postulates back in the postulates section in 2.5, but we really don't need to give a name. They're marked as being the same because they're both 90-degree angles. Which brings us to the other 2 set of angles, and those are based on these symbols. Those symbols indicate that AB is parallel to CD. If AB is parallel to CD, okay, if AB is parallel to CD, then AC is a transversal, and these angles should have a very familiar property to us. Those 2 angles that I just marked must be congruent if AB and CD are parallel, because those 2 angles are alternate interior angles. Now the downside is we can't use the single letter naming method here because there are multiple angles with a vertex at C, there are multiple angles with a vertex at A, so we have to use the 3-letter naming method here. Okay? Angle BAC is congruent to angle DCA. Okay, let's go over those real quick with a highlighter so we can see them. The reason we're using the 3-letter method again is there are multiple angles with a vertex at A. The one we want is BAC. See how that's that angle? And on the other one, DCA. And it's great that my highlighter just screwed up there. It's going to take me a minute to get rid of all those marks. Okay. All right. Using similar reasoning and the other set of parallel marks, so this is indicating that AD and BC are parallel. If AD and BC are parallel, then these angles that I'm marking with 2 dashes are also alternate interior angles. And since AD is parallel to BC, those 2 angles must also be congruent. So that would be angle BCA must be congruent to angle DAC because they also are alternate interior angles. Again, we'll go over those real quickly. The 3-letter method, angle BCA is that angle, and angle DAC is that angle. Okay, so we've managed to get all 6 of our statements. We have 3 different sides marked, 3 different angles marked, which means that the triangles are congruent. So that just leaves the triangle congruence statement. And this is a little bit tricky, so let me do the best I can to explain this, okay? When we write a triangle congruence statement, it does not matter at all which triangle we name first, or even what order we name the vertices of that triangle. So let's say that we're naming this top triangle. It has vertices A, B, and C. It does not matter what order we name this triangle. We could say triangle ABC, we could say triangle BAC, we could say triangle CAB. It makes no difference. We just need to name it. So let's stay traditional. Let's call the first triangle triangle ABC. Okay, so once we name the first triangle, it doesn't matter how we name the first triangle, or even which triangle we name first. But let's say we choose to name the top triangle ABC. Once we have made that decision, there is a very specific way that we have to name the other triangle. See, the name in the congruent statements, they have to match up to tell us these 6 statements. So once we've decided that we're going to name the first triangle A, B, C, we've made the decision to list those angles 1 mark, boxy, then 2 marks, which means that when we name the other triangle, we have to use that same order. A, B, C was 1 mark, boxy, and 2 marks. So the other triangle has to be named 1 mark, boxy, and 2 marks, or C, D, A. Now, there's another one of these in your notes, so please try that one now. Pause this video until you have tried that one. Don't just watch the solution. Give it a shot first, then watch the solution to see how you did. Here is the other example. Hopefully you paused the video and you're resuming it now to check your answer. Again, our goal here is to show all 6 of our congruent statements, 3 sets of sides and 3 sets of angles, and then write out a triangle congruent statement for this picture. The 3 side links, those should be easy because they are all marked. Segment AE is congruent to segment DE. Those each have 1 mark. Segment BE is congruent to segment CE because those both have 2 marks. And segment AB is congruent to segment CD because those each have 3 marks. The angles are where we really have to think, okay? So all 3 sets of angles are based on rules that we should already know. We have a set of parallel markings indicating that AB and CD are parallel. If AB and CD are parallel, then AD is a transversal, and angle A and angle D have to be congruent. The reasoning behind that is that angles A and D are alternate interior angles, and the alternate interior angle theorem says they have to be congruent if AB is parallel to CD. Using the same argument, but replacing AD as the transversal with BC being the transversal, we can make the exact same argument about angles B and C. Angle B must be congruent to angle C because if BC is the transversal and AB and CD are parallel, then those are alternate interior angles, and the alternate interior angle theorem says they must be congruent. The third set of angles is located here in the middle. So we need to come up with a reason why these two angles would be congruent. Well, hopefully that's probably the easiest one to realize why, even though it's the hardest one to name. There are multiple angles with a vertex at point E, so we have to use the three-letter method. This angle is named angle AEB, or BEA, doesn't matter which way you name it. And this angle is DEC or CED. It doesn't matter which way you name it. Those angles are congruent because they are vertical angles, and the vertical angle theorem says vertical angles must be congruent. So that leads us to our triangle congruence statement as our final step to the problem. Again, it does not matter at all what order we list the name of the first triangle. So let's say we name this top triangle first, and we name it triangle ABE. Once we've made that decision, and again, it doesn't matter which triangle we name first or even what order we name the 3 points in, what does matter is that we match the name. Okay, so in that triangle we said ABE, which is 1 mark, then 2 marks, then 3 marks. So when we name the other triangle, we have to match that. 1 mark, then 2 marks, then 3 marks, meaning we have to name the other one triangle DCE. Triangle DCE. Okay, that does it for the first video. The second video over this section is going to cover the theorem, the new theorem for the section, which is called the third angle theorem for triangles. It will show the proof of that theorem, and it will show a couple of algebra-based examples. Thank you very much for your time.